Texas Instruments has developed a graphical tool to make the process of coding the MSP430, especially configuring the peripherals, much easier. This tool is called Grace. In Section 8, you'll take a look at the benefits that tool can provide.
Grace is a free graphical user interface that generates source code and eliminates manual peripheral configuration. We've spent the entire class up to this point doing all the configuration on every one of these peripherals by hand. It would be really nice if we had a tool that would make this simple and do it for us. Let's take a look at how Grace operates. The intent of Grace is to simplify the peripheral configuration, to allow you to fully harness the MSP430 integration for free, to visually enable and configure the MSP430 peripherals. It will generate fully commented C code on all F2XX and G2XX value line microcontrollers. Fully commented, human readable code, not some kind of strange stuff that you can't understand what's going on. It provides a series of different levels of abstraction, basic, power user, and register views, whatever you're comfortable with. So you can get started quickly and learn as you go. That way you can come up to speed to get rapid understanding of how the MSP430 peripherals and what configuration options are available to you. It will guide you through the peripheral integration with tooltips and pop-ups, and it prevents configuration conflicts like trying to use the same pins for two different things or collisions between the peripherals. You can also create your designs in a familiar development environment. It's a plug-in for Cocomposer Studio, so we've been working with Cocomposer Studio already. Grace is just a plug-in that allows you to work directly in that. It seamlessly includes the peripheral configuration code into your Cocomposer Studio project, and it loads and debugs just like you'd written it yourself. So Grace lets you visually enable and configure MSP430 peripherals. The diagram over on the left shows you the MSP430 X22X4. You can see a diagram there that shows you an overview of what's inside the part. The basic clock system is in blue, the flash and the RAM, the ADC10, the port, the op amps, the ports, the Watchdog Timer, and so on. Those devices that can be configured are in blue. Those devices that have been configured have a check mark next to them. So the basic clock system, you must configure the basic clock system, so some basic configuration has been done. You can see here that the ADC10 has been clicked on, and here the first thing it asks you is whether or not you want to use the ADC10 in your configuration. If you check that, you then get the basic user, power user, and registers buttons to click on. So you can interface to this tool with buttons, drop downs, and text fields to navigate high above the low-level register stuff that we've had to deal with before. And like I said, it generates fully commented C code for all F2XX and G2XX value line microcontrollers. So you as the developer get to choose the view of the peripheral that's most comfortable and most useful for you. It offers a variety of views, so it accommodates your skill level and preferences so that you spend less time configuring the low-level peripheral setup code and more time for the product differentiation that's going to matter to your customer. If you take a look in the upper left, you'll see the basic view. We want to configure the A to D converter, so we want to tell it things like the sampling rate. We want to tell it the signal bandwidth and which ADC channel that we're talking to. And then we're checking whether or not we want to enable the A to D converter interrupt. We tell it what interrupt handler we're going to use, and we're basically done. In the power user view, we get additional settings that we can make. All the ones that we made in the basic view, plus some others. In the register view, we can get all the way down to the bit fields that make those selections. If you make a selection in the register view, you can go back to the power user view, and those selections will be mirrored in that. If you make selections in the basic view and go down to register view, you'll see that those selections have been made. throughout the workshop till this point, we've emphasized the idea of going back to the data books, making sure of what we're telling you is correct, that the bit fields we're telling you are correct, that the bits are correct, that the APIs are correct. The content inside of Grace, as well as the look and feel, is completely based on the MSP430 user guides and data sheets. The tooltips and pop-ups will look exactly like the data sheets did, and they will guide you through the peripheral integration. When we go in to create a new Cocomposer project, we can go in and select a template that actually is from the beginning an empty MSP430 Grace project, so that you can begin to write your code right away. If you would rather pick a Grace example and work with that, there are a series of examples that you can start with, so you can get started with your application development from there. So Grace makes it easy for both those familiar with the MSP430, hopefully like you are already, and those new to it to get started. Another feature of Grace is to prevent collisions and contradicting configurations. You will get instant notification of configuration errors when you're trying to do something wrong, and it ensures interperipheral communication configurations are consistent if you're trying to talk from one thing to the other. Edits and changes that are made in one peripheral can be reflected in other modules, and if you make changes in the basic view, that will be reflected in the power user and register, and vice versa. You can see up at the top here in the diagram, it's telling you, nope, you can't do that based on what you've done before. That way, we prevent you from getting to a point where you run the code and don't know what's going on. Grace works directly inside Cocomposer Studio. It's a free plugin for CCS. In fact, since you have 5.1, it was already part of the download. The code generated by Grace is directly inserted into your active CCS project environment, and then you can go in and debug the code and download it into an MSP430 just like you had written it yourself. In fact, if you like the code that's generated there, you can cut and paste that and take it into your own code. Like I said before, Grace seamlessly includes your peripheral configuration code into the CCS project so that you can debug and download just like traditionally written code. As I've tried to show here in the diagram at the bottom, you can see that I have my source files, and then CSL, which is the chip support library, and then within that are all the files that Grace has created. Among them, the ADC10 init, the clock init, the CSL init, which is the high-level initialization for all of these, GPIO, and etc. So I've opened up ADC10 init in the edit window, and you can see that it includes the header file for, in this case, the 2274, and then the ADC10 initialization is right there. So it says control register 0, control register 1, there's a software delay, and so on. But you can see throughout there it's used human readable code, fully commented human readable C code has been generated right there. So now you can just insert that directly into your project. If you like this ADC10 initialization, take this file and include it in some other project that you want. The code's completely reusable. Grace supports MSP430's most popular tools, the F2XX and G2XX value line microcontroller. The LaunchPad here, the EZ430 RF2500 on the left, the EZ430 F2013 there on the right. Grace also works with the flash evaluation emulation tool, the FET, and target boards like the ones that are listed here. If you don't already have Grace, or if you have a different version of Cocomposer, you can go to www.ti.com/Grace and take a look at the great capabilities that Grace provides.
In Lab 8, you'll create a simple project to blink the LED using Grace. You will be able to program this application much more quickly than you would have previously been able to do without even opening a data book. Let's get started creating a Grace project. Grace is part of the Cocomposer Studio 5.1 installation. Create a new project by clicking File, New, CCS Project. Go ahead and make the selections shown in the workbook. Again, if you're using the 2231, make the appropriate choices for that part. Make sure this time that you select Empty Grace MSP430 project before you click Finish. Step 2, welcome to Grace. The Grace welcome window will appear in the editor pane of Cocomposer Studio. If you ever manage to make this screen disappear, simply reopen the CFG file. In this case, it's main.cfg in Cocomposer in the project window. When a Grace project is open, the tool creates this configuration file to store the changes that you make. Click on the Device Overview button in the Grace window. Grace presents you with a graphic representing the peripherals on the MSP430 device. This isn't just a pretty picture. From here, we'll be able to configure all of the peripherals. The blue boxes that you see denote peripherals that can be configured. Note that 3 of the blue boxes have a check mark in the lower left-hand corner. These check marks denote a peripheral that already has a configuration. The ones already marked must be configured in any project in order for the MSP430 to run properly. Again, if you're using a MSP430 G2231, your Grace window is going to look a little bit different than this. In step 3, let's start at the top. Earlier in this workshop, we measured the DVCC on the board at about 3.6 volts. Change the pull down at the top to reflect that. Next, click on the blue Basic Clock System Plus box. Note that the navigation buttons at the top for the different views. These buttons may disappear if the window is large enough and you slide to the bottom. If they do, slide back to the top. Also note that the navigation buttons on the top right of the overview screen and the tabs at the bottom left. Take a look at the different views, but finish by clicking the Basic User button. The default selections have the calibrated frequency at 1 MHz for the high-speed clock source and 12 kHz for the low. Note the simplified view of the M clock, SM clock, and A clock. If you need more detailed access, you can switch over to the Power User view or Register view. In any case, leave the selections at their defaults and click the Grace tab on the lower left. Let's configure the Watchdog Timer next. Click on the blue Watchdog Timer WDT Plus box in the overview graphic. Note the selection at the top enables the WDT Plus. Click the Basic User button. Stop the Watchdog Timer is the default selection. Let's leave it that way for now. Click the Grace tab in the lower left. GPIO is next. For this lab, we want to enable the GPIO port pin that is connected to the red LED, that's port 1, pin 0. Click on the upper right blue box marked port 1, port 2. It says port P1, port P2, port P3. In the next screen, click on the buttons marked Pinout 32 QFN, then Pinout 20 TSOP, and Pinout 28 TSOP to view the packages with the pinouts clearly marked. If you're using the 2231, your package selections will be different. No data book required. We could make our changes right here, but let's use another view. Resize the Grace window if you need to do so. Click the P1, P2 button. The direction registers all default to inputs, so check the port 1, pin 0 direction register to set it to an output. No other changes are required. Click the Grace tab in the lower left. In step 7, we're going to use the timer to give us a 1-second delay between blinks of the red LED. To configure the timer, click on the blue box marked Timer 0 under A3. This is going to be Timer 0 under A2 if you're using the 2231. In the next screen, click the checkbox marked Enable Timer A3 or A2 in My Configuration. When you do that, the View buttons will appear. Click on the Basic User button. In our application code, we're going to put the CPU into low power mode LPM3. The timer will wake up the CPU after a 1-second delay, and then the CPU will run the ISR that turns on the LED. Our main code will wait long enough for us to see the LED, turn it off, and go back to sleep. So we need to make the following settings for the timer. Our timer selection should be interval mode / TA0 output off. Our desired timer period is 1,000 milliseconds. That's 1 second. We need to enable the capture compare interrupt. And we're going to give since we've enabled the interrupts are going to go off, so we need to have a named interrupt handler. That will be timer ISR. Make sure you spell this right, by the way. After interrupt, you want to go back into active mode, meaning we're not going to drop directly back into LPM3. We actually want to go back and interrupt the code that's going on in the while loop. Make those settings, then click the Grace tab in the lower left-hand corner. Note the configured peripherals now all have a check mark on them, the ones that you have checked. The outline pane on the right of your screen also lists all the configured peripherals that you've touched. Step 8, I'm sure you remember that without the GIE, the Global Interrupt Enable bit enabled, no interrupts occur. At the top of the device overview window, click on the System Registers button. Find the GIE bit in the status register and make sure it's checked. If your MSP430 G2231 configuration has an Enable checkbox, make sure it's checked. Click the Device Overview button. We're done with the Grace configuration. Click the Save button to save your changes. At this point, we're done configuring the peripherals for this entire application. So you can imagine the time savings. Well, Grace automatically creates a main.c template for us with the appropriate Grace calls. Double-click on main.c in the Project Explorer pane to open the file for editing. So you should see the MSP430.h file in there. You should see some Grace-related includes like CSL.h, and then there's our main code right there. The standard MSP430.h definition file is included first, followed by the Grace definitions. In the main declaration, note argc and argv. Those are standard arguments for a C main function. They allow users to invoke an application with a command line argument. Argc is the argument count, argv is the vector. Inside main is CSL init. That runs all of the Grace initialization that we've just configured. In step 10, let's modify main a little bit. Remove the arguments in the main declaration. We're not going to use them. And then remove the return at the bottom. We're not going to return from main. In order to save some space in the workbook, we remove some of the comments. You don't have to remove those if you don't want to. So the only thing that you should have inside main at this point is CSL under init. In step 11, the first thing we want the main code to do is to place the device into low power mode 3. When the timer expires, the timer ISR code will turn on the red LED. Our main code will wait a short time, then turn off the red LED. Add the while loop as shown below. So if the timer turns on let's say the timer goes off, right? It turns the LED on. It lets the while loop run, which then enters LPM3. There's a 10 millisecond delay, so the interrupt is actually going to occur between the first and second instructions of the while loop. Then there's a 10 millisecond delay. We turn it off. We go back. We turn it off. That way we'll actually be able to see the LED blink here. In step 12, now we can add the timer ISR code that turns on the red LED. So make your code look like this. All we've done is added a timer ISR. We've added the P1 out and bit 0. You'll notice this is a little bit different for making an interrupt service routine than we've done before. You'll notice that the pragma is missing. All of that is already done by the Grace tool. So now, build, load, and run. Make sure your LaunchPad board is plugged into your computer's port. Build and load the program by clicking the debug button. If you're prompted to save anything, please go ahead and do so. Step 14, after the program has downloaded, go ahead and click on the Run button. If everything's correct, the red LED should flash about once every second, and ours is working. Feel free to go back and vary the timing if you like. You can also go back and rerun the rest of the labs in the workshop using Grace. If you're so inclined, open the Lab 9, go back to the editing window, open the Lab 9 under Source, under CSL folder in the project panes. Not in the Project Explorer. There will be a Source CSL. SRC CSL. You can walk your way through the fully commented C code generated for each of the initialization files. If you like the way that this is done, you can cut and paste the code into a non-Grace project if you choose. This was a very simple example. In a more complex example, the power of Grace would be even greater, and your project development would be much further along than it would have been if written entirely by hand. Terminate the debugger, close the Lab 8 project, and exit Cocomposer.